Hey, good evening guys. So today I'll be making a short tutorial video on functions. Okay, functions and derivatives, right? The functions and derivatives, okay. So the thing about functions is that we're actually going to focus on a specific part of functions in our tutorial, and that would be limits. Okay, that would be limits. So what is a limit actually? So a limit, right, by definition, is to investigate or to find if there is continuity. Okay, there is continuity, right? I'm sure I spelled the word continuity right. At a function fx, okay, which is defined fx, at a point, okay, when x is a, okay. And how do I demonstrate this graphically? Let me just draw a simple graph right here. Okay, x and fx. Okay, and I draw a function. Okay, let's just use the cosine function, right? The cosine graph that you guys are familiar with. Okay, and let's just say this is our point A. Okay, this is our point A. So as x approaches A, right, what we can see is that at fa is equivalent to 0, right? So meaning to say that when we write the limit in the mathematical sense, okay, the limit as x approaches A for fx, we can clearly say that it's 0. And we also see that it's continuous. The function actually, right, for the shaded in blue, it's going right through A without any breaks, right? So there is no break whatsoever. It's really smooth. It's just going in this very nice looking line, right? This nice looking curve, actually, cosine curve right there, very beautiful curve. Okay, so it's not, there's no breaks whatsoever. Okay, so there is no breaks. So thus fx is continuous at x equals to a. Alright, so how do we solve limits? How do we normally deal with limit problems? So there are two ways that we've learned. One way is obviously through factorization. Okay, factorization. And another way is through L'Hopital rule, right? Okay, and I'm gonna explain a bit about the two. Let me just erase this real quick. Okay, so for factorization, which is normally the common way to do a limit, let me just give a problem very straight away. So let's say we have a problem, right? Limit as x approaches 0, we have your x, and I have here x squared minus x. Okay, so there seems to be a bit of a problem, right, when we try to solve the limits normally, because when we try to solve the limits from top and bottom, what happens is that as we put x is 0, so what happens is just 0 square minus 0 over 0. So we get 0 over 0, which is obviously, right, not possible. It's undefined, right? If you were to type this on your calculator, this is what we're going to get on the calculator. It's undefined, right? So how are you going to solve this problem? So one way is obviously through factorization, right? Through finding a common factor. So in this case, if I were to solve by factorization, or algebraic manipulation as I like to call it in fancy terms, so I can just factor out the x. It just becomes x minus 1 over x. Okay, and we can see that it's a common factor. We can just cancel it out, and what we'll end up having is quite simply the limit, okay, when x approaches 0 at x minus 1. Okay, so it becomes 0 minus 1. The answer is negative 1. Okay, this is by factorization. Now Another rule that we could do is the L'Hopital rule. It's a very special rule actually that's used in calculus, but it has its I would say it has its requirements or restrictions, I like to put in other words. So L'Hopital rule, okay, let me just erase this real quick. Okay. So L'Hopital rule, what does it state is that, let's say if you have a function, oops, what, pen mode? Let's say you have a function, okay, limit as x approaches a, in the form of fx over gx. And let's say we were to substitute this a, okay, we put here fa over ga, and if we get a result like before where we got 0, 0, or we get in terms of infinity over infinity, then we can actually use the L'Hopital rule. So L'Hopital rule basically states that the limit of a function as x approaches a, fx, okay, function 1 over function 2 gx, is equivalent to the same limit, but we take the derivatives of fx and we take the derivative of gx, okay, and once we take it, we should be able to get our intended limit or intended answer. And if we don't, the neat part is you can do the differentiation again until you do. So yes, you can keep doing it again until you get the intended answer. Alright, so that's basically L'Hopital's rule. Right, so going back to our previous problem, alright, so our previous problem, we were just to discuss it earlier. Right, where was I? Okay, let's use blue. So our previous problem was what? We have a limit as x approaches 0, x squared minus x over x, right? Well, obviously we end up getting 0 over 0, right? So if you were to use L'Hopital's rule, we take the derivative, okay, of this x, okay, we call it as gx, by the way, and I'm going to take the derivative of this, which we call it as fx. Cool. So we do the derivative. What happens is that we'll get limit as x approaches 0, right? So we'll end up having 2x minus 1 over 1, right? So what happens is that we get 2 times 0 minus 1 over 1, so it just becomes negative 1 over 1, so it becomes negative 1. So yeah, that's our answer actually, right? So we can go at either method really. You can either go at factorization, okay, you can either go at factorization or L'Hopital rule, it doesn't really matter, but I preferably like L'Hopital rule because sometimes it's usually faster than factorization, because in factorization you always need to find the right factor, right? Whereas L'Hopital rule, you can just straight away differentiate the functions. But again, there's a limit to L'Hopital rule actually, alright? There's actually 3 important things you have to make sure. You need to make sure your function is always in the form of fx over gx. That's number 1. Number 2, you need to make sure your function always, the original limit would be either 0, 0 or infinity over infinity, okay? If let's say that your function ends up being 1 over 0 or let's say infinity over 0, it becomes other indeterminate forms, then rule not applicable, rule not valid. And usually in those cases, if let's say you end up getting 1 over 0 or this, right, then usually the limits don't exist, alright? Sometimes the limit don't exist or doesn't exist, okay? Or it can be infinity itself, right? Negative infinity or whatnot. It depends on the problem, but usually that's the case. If you end up having 1 over 0, infinity over 0, normally it will be infinity, right? So the limit would be infinite, so it would really not exist, to be honest, because it will keep on diverging. In this case, it will keep on diverging, okay? So I hope this is clear. So we're gonna do some practice questions from the textbook. Okay, let me just erase this real quick. And yeah, right, let me erase this. Okay, great. That's a big brush. Okay, so let's go to your textbook right away. Right, so the first question, okay, so the first question we're given here is that we have a function, right, whose limit is simply as x approaches 0. The form is like this, okay, it's just root 1 plus x minus root 1 minus x over 3x. Okay, so what I want you guys to do is to pause this part of the video and try to solve the limits yourself. Either you can use factorization or L'Hopital rule. Okay, so if you guys already given an attempt, let's try to work out with factorization in this case, because I think it's possible to do this with factorization. So let's just multiply with a common factor here, since our common factor would be root 1 plus x plus 1 minus x. And we're also going to do the same here. So it's going to be root 1 plus x plus 1 minus x. Okay? With that being said, let's solve the problem. So limit as x approaches 0. So of course we multiply these two, we'll end up having 1 plus x. And this is of course, you know, minus plus, right? It's similar to, like, for example, you have a plus b and a minus b. You'll end up having what? A square minus b square, right? So similarly for this, you multiply together, you get to the power of 1, right? Minus 1 minus x. And then you'll have here 3x. Of course, you'll end up having this, right? So it becomes 1 plus x plus root 1 minus x. Okay, so as we proceed, so as x approaches 0, okay, so you end up having x plus x, so we'll end up having 2x, right, over 3x root 1 plus x plus root 1 minus x. Okay, so we can see there's a common factor, right, between the two. Just simply x, right, which will always become 1, right, in this case. Then we'll end up having limit as x approaches 0, we'll end up having 2 over 3 bracket 1 plus x plus root 1 minus x. Okay, as we solve the limits, okay, let me just grab my calculator real quick. It's just 2 over 3 root 1 plus, sorry, 3 over 3 plus 0 plus root 1 minus 0. Quite simply, you got your answer, which is obviously gonna be 1 over 3. Okay, so that's how we do it, by factorizing. Okay, so this is the first method that we just employed, factorizing. Now let's say if you guys wanted to do the L'Hopital rule, okay, how do we do it by L'Hopital rule? Actually, we can also do it by L'Hopital rule, but it'll just be a little bit, you know, I would say a bit tedious, because you have a bit of factors here, but it shouldn't be a problem whatsoever. Let's do it by L'Hopital rule. Yeah, okay, so erase apparently. So oops, let me just make the eraser a bit smaller. Excellent. Okay, now erase this all real quick. Okay, perfect. Let's go back to the pen. So now we do L'Hopital rule. Okay, we try to solve this by L'Hopital rule. To solve this by L'Hopital rule, actually, alright, I'm going to denote this as gx first of all, and I'm going to denote this as fx. Okay, so for gx, if you take the derivative of gx, it's pretty straightforward. It's just simply 3. But for fx, okay, if we take the derivative of fx, it will become what? It will become half, right, 1 plus x to the power of negative half minus half, okay, 1 minus x to the power of negative half. Oh, don't forget to multiply by negative 1. And this one obviously is positive 1, but I didn't consider it. But anyways, so if we were to simplify this, it would just become half 1 plus x to the power of negative half plus half 1 minus x to the power of negative half. Okay, so that's about it. Now what we can do also is that we can find the limit for these individual components as well. So limit as x approaches 0 for g prime x is obviously going to be 3, right, because it's a constant. Whereas for the limit, if we were to do for f prime x as x approaches to 0, it'd be what? So it would have just been half plus half, right? It would just become 1, correct? So in this case, if we do the L'Hopital rule, so our answer would clearly be 1 over 3, right? It's just simply because it's just f prime x over g prime x. So there you go. That's L'Hopital rule actually. So, you know, you could do either one method. There's no problem whatsoever. And yeah, let's do one more question. Right, let's do one more question right away. Okay. Okay, let's see. Okay, let's see what's an interesting question we have right here. Okay, let's do a second question. Okay, so now this is going to be an interesting question here. So it's going to be limit as x approaches 0, right, sine inverse 2x over x. So I want to give you guys a pause actually. Like, try to pause the video and try to give this a go. See which method would work best. Is it factorization? Is it L'Hopital rule? And then later we can try out this problem. Okay, so we're back now. Now I think if you guys already noticed, actually factorization is not possible for this because there's no common factor to factorize out these two, right? It's not that simple. So the only way we could actually proceed with this is probably L'Hopital rule. But how are we so sure if we can proceed with L'Hopital rule or not in this case? How are we so sure? So let's just try to plug in the limits as it is. So we know that sine inverse 2 times 0 would end up with 0, and we know that x we put is 0. So since it's in the form of 0 0, which is obviously again undefined, right, it's not what we wanted, but we know that L'Hopital rule is clearly applicable for this case, right, because it's 0 0. So in this case I'm going to take it as my gx, and I'm going to denote this as fx. Okay, so for fx, if we find the derivative of fx, we need to find the derivative of sine inverse 2x, by the way. And if I'm not mistaken, the derivative of sine inverse is just simply x, yeah? It's just simply 1 over square root 1 minus 2x squared times, obviously because we're differentiating the 2 as well, so it becomes just 2. So therefore it would just simply be 2 over root 1 minus 2x squared. And as we try to approach to 0, okay, the limit of x approaching 0, what would it be? It's just simply 2 over root 1 minus 0 will just simply be 2, right? It's just 2 over 1, it's just 2. Okay, now for g, we find the derivative of gx is just simply 1. So thus the limit of g prime x, okay, as x approaches 0 is just clearly 1. So in this case, the limit would just simply be 2 over 1, which will be obviously 2. So there you go. Alright, so that's basically how do we solve it for this case. Okay, so yeah, that's basically how we solve for this question, by the way, where we had to use L'Hopital's rule. Alright, so now we're coming with one last question of the day, right? And this is going to be quite an interesting question. Let me see. Okay. Let's see. Okay. Last question, yeah. So we have this question right here. So we have a limit as x approaches to pi over 2, okay, sec x, by the way, minus tan of x. Okay, and if you guys need a hint, remember that secant of x is just basically the reciprocal of 1 over cos x. So I'll give you guys the time to pause for a bit and solve this problem. Okay, how are you going to solve the problem? Are you going to use factorization or are you going to use L'Hopital rule? Right? And yeah. Okay, so I assume you guys give a shot at this problem, and this problem is a bit interesting actually, I would say, because we're having two different trig functions. We have secant of x and a tangent of x, right? And I already given you the clue that the secant of x is just basically a reciprocal of cosine. And if you guys need to recall what tan x is, the tangent of x is basically also a reciprocal of cosine. Well, you know, it's just sine x over cosine x, really. That's it. So in this sense, we can rearrange it algebraically. So just a limit is just simply x is just pi over 2, right? It's just simply 1 over cosine x minus sine x over cosine x, right? So it's quite simply one minus sine x over cosine x. Okay, now before we proceed with L'Hopital's rule, let's actually make sure if we can or we cannot. So we're gonna do 1 minus sine. Okay, we're just gonna simply input 1 minus sine pi over 2. We're just gonna substitute in and see if we get the indeterminate form that we're looking for. 0. Okay, so the top is 0. The bottom should also be 0 as well, because cosine of pi over 2 is 0. So yeah, so therefore we can obviously use L'Hopital rule, right? We can definitely use L'Hopital rule straight away, right? So I'm just gonna use this part, obviously, right? And we know, right, we're gonna take in the form of gx, by the way, and I'm gonna use a different color for fx because we're already using blue too many times. Oops, that's actually very fast. Okay, cool. So we know that fx is just 1 minus sine x, so the derivative would just simply become cosine of x, and as the limit, okay, approaches to pi over 2, okay, for negative cosine of x, right? So you're just put negative, well, it's still 0, okay. And then for gx, right? We know that gx is just simply cosine of x, so the derivative is just negative sine x, right? So when we put the limits as x approaches to pi over 2, right, and we put negative sine x, what do we end up getting? So sine pi over 2 with negative 1. Okay, so negative 1. So in this case, our limit would become 0 over negative 1. So it's clearly going to be a 0, right? Because 0 divided any number is 0. So that's basically our answer if we are solving it, right? Okay, so yeah, that's how we do it, the L'Hopital rule for this question. Now, should we do one more question or not? You know, kind of thinking actually if we should or should not do the question. Okay, we could give this one a try. Okay, just for the fun. So we're gonna do one last limit question, by the way, before we conclude the end of this video. Let me just give a different kind of question, maybe not something to do with trigonometry. Okay, let's look for a question here. Let's see right here. Where can I find this question? Okay, let's try this question right here straight away. Okay, so last question of the day, question 4. So if we're given a function to find its limits at, let's say, obviously at x approaches 0, and we are given a function like this, so 1 minus x, right, over 1 over 4 over x. Okay, so I'll give you guys some time. I'll just pause this video for a little bit, and then after that we could solve the problem together. Okay, okay, so I assume you guys have given it a shot. So maybe you guys are thinking, why don't we factorize this problem? Okay, let's just give it a try. Let's just see if we can factorize it. Okay, let's just see if factorization will work. Okay, so what we try to do, right, we have a function right here, so limit as x approaches 0. Of course we have 1 minus x, right, to the power 1 over 4, right, over x, and I'm going to multiply this with 1 plus 1 minus x to the power of 1 over 4. And the same also right here, so 1 plus. Okay, as we try to solve this problem, right, with factorization, we'll end up having we'll have 1 minus, well, 1 over 4 plus 1 over 4, what do we end up getting? We end up having 1 minus x to the power of half. Okay, oops, let's make that a little bit more clear. I think the half symbol is a bit weird. Okay, and we end up having x times 1 plus 1 minus x to the power 4. Now this seems a little bit more tricky, right? I mean, now we're having a bit of a problem actually, because we know that the bottom part will end up giving us a 0, right? And the top part will also end up giving us a 0 as well. So factorization itself isn't really the way, right? It gives you a much more complicated function, and obviously you still get the same problem 0 over 0. So that means the best way we could do is using the L'Hopital rule actually for this, right? We can use the L'Hopital rule, by the way. Okay, so we have to use the L'Hopital rule. So L'Hopital rule actually, it's far easier. Okay, if I take this as my fx, for instance, and I take this as my gx, okay, so what I'm going to do is obviously find the derivative. So f derivative of course would be what? Negative 1 over 4 1 minus x to the power of what? This 1 over 4 minus 1 would give us, well, it will just give us negative 3 over 4, right? And the limit as x approaches 0 of f prime x would be what? So just negative 1 over 4 1 minus 0 to the power of negative 3 over 4. So it will just be negative 1 over 4 at the end of the day, right? And for gx, if we do the derivative, we get 1. So the limit as x approaches 0 for g prime x is clearly 1. So we have negative 1 over 4 divided by 1. So our final answer would just simply be negative 1 over 4. So that's our limit, right? As x approaches 0, right? That's what we end up getting. We end up getting negative 1 over 4. Okay? So, you know, I think that's pretty much about it for limits, honestly. There are again two methods we have. One is obviously factorization, another is L'Hopital rule. Okay, and both are very good ways to solve limits, by the way. You can either use factorization or you can use L'Hopital rule. Okay, and it really depends on which method you find the most suitable to use actually. Okay, L'Hopital rule generally can be faster, right, compared to factorization, because you don't have to find the factor itself. All you have to do is just simply differentiate. That's all you have to do for L'Hopital rule. Differentiate, yes. Okay, whereas for factorization, always have to find its common factor. You always have to find what is this common factor I can use to solve the problem, and that's not always very easy, right? Sometimes it may seem intuitive, right, but in the end of the day you're going to be stuck with the same problem, and this will be a very huge roadblock for you to solve the problem. Whereas if you use L'Hopital rule straight away, you know, you just differentiate the top. Okay, well, I'll just make it white. If you just differentiate the top and you differentiate the bottom, and voila, you get the answer straight away, right? But there's also a limitation to L'Hopital rule. For L'Hopital rule, the function must be in the form of f over x over g over x. G over x. And when you do the limits for it, normally it should either give you the output as 0, 0 or infinity over infinity, right? If it gives you any other output, like maybe for example, if your limit of the function, right, as x approaches a, and we have here fx over gx, okay, if it gives you, right, 1 over 0 or negative infinity, right? So 1 over 0 clearly is infinity, by the way. It's not infinity over infinity, right? So therefore L'Hopital rule is not applicable. So L'Hopital rule is not applicable. Okay, so hopefully that makes you guys understand actually on the methods to use for limits. Alright, and yeah, that's pretty much about it. I hope you guys, practiced, right, the questions I've given you. And if you guys have any questions, right, if you have any problems, please feel free to reach out to me on WhatsApp, right, or on YouTube as well. You can comment, there's no problem at all. So thank you guys for watching. See you next time.